Hey guys, so you did a really great job today with the absolute value equations. So we're going to go ahead and move on to absolute value inequalities. So make sure that you summarize all the information that you receive from this video. Write down any questions that you have regarding the information that you were given. And what else? Oh yeah, just, have fun with it. So let's go ahead and have you guys pause this video so that way you can jot these two equations down. The absolute value of x equals 7 and the absolute value of x equals negative 18. That way you can go ahead and solve them and we'll see how well you do. All right, so if you happen to say that the absolute value of x equals 7 is x equals plus or minus 7, x equals positive 7, or x equals negative 7, then ding, 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 you're correct. Yay, woohoo! All right, but how about the absolute value of x equals negative 18? Well, if you recall from yesterday's lesson, I told you that the absolute value cannot equal a negative. So in this case, there actually is no solution. So if you went ahead and said that and got that correct, then I am super duper proud of you. And sorry, no extra credit for you, but I mean, pat on the back. You did great. All right, let's do one that may be a little more challenging. It probably really isn't, but the absolute value of x minus 3 equals 12. So go ahead and pause this so you can jot this down and work it out and find out what two solutions there are for x. All right, if you recalled that you had to write this without the absolute value symbol, and then go ahead and move that minus 3 over by addition, so it cancels there, adding it to 12 and saying that x is 15, one of the possible solutions is 15, then you're correct. Yay! Kudos for you. How about the other value that x can be? I'm not going to tell you what that one is. Go ahead and make sure that you do have this one worked out for tomorrow, because I'm definitely going to check that tomorrow in class. So let me know tomorrow in class, what's the other value for x if the absolute value of x minus 3 equals 12? All right, so you're going to recall that the absolute value of a number is talking about that number's distance from the origin, how far that number is from 0 on the number line. So when we say that the absolute value of x is 3, what we're saying is that, well, what numbers are 3 places away from 0 on the number line? And you recall that that's going to be negative 3, because that's 3 places to 0. Positive 3 is also 3 places to 0. That is going to be super helpful in order for us to be able to interpret absolute value inequalities. So what I'm going to do here is I'm just going to get rid of that equal sign, and now I'm going to change it to an inequality symbol. And yeah, we'll go with this. The absolute value of x is less than 3. So go ahead and jot this example down so we can work it together. All right, so with this inequality, what we are looking for is all of the numbers whose distance from 0 is less than 3. All of the numbers that are less than 3 places away from 0 on the number line. All right, so we can think of numbers whose distance from 0 on the number line is less than 3 places. Numbers like negative 2, that's less than 3 places away from 0. Let's go with, how about 1.5, 1.5, that's also less than 3 places away. Even negative half, negative 0.5, running out of room over there. Even that is less than 3 places away from 0 on the number line. So let's look at what a graph of this inequality should be. So the graph is going to look just like this. As you can see, I have shaded all the numbers on the number line that are in between negative 3 and positive 3, because all of those numbers in between negative 3 and positive 3 are the ones whose distance from 0 is less than 3 places away. So really what this graph is showing is two things. It's showing that I have values for x that are greater than -3, and those values for x are also less than +3. So let's go ahead and talk real quick about why I used the word and. Why didn't I use or, since we've talked about that as well? Let me tell you why I used and. When my original inequality is using less than or less than or equal to, then that means that that's going to be a conjunction, and I will use the word and. Remember that with a conjunction, when we use the word and, we are looking for basically everything that the inequalities have in common, where their graphs would overlap. On the other hand, if I am using, in my original inequality, the greater than or greater than equal to symbol, then that means I'm going to use the word or and make it a disjunction. And basically, I would want to make sure that I'm showing everything on that graph for the inequalities. Not just where they might overlap, but just everything for the inequalities. So let's take this next example. The absolute value of x is less than or equal to 4. So what I'm looking for here is all the numbers whose distance from 0 is smaller than 4 or actually equal to 4. So let's go ahead and recall that when we have our less than or equal to, on the graph we get closed circles. So I'm going to go ahead and make sure that I fill in a closed circle at 4 because we're saying we're including 4 in this, that it's 4 places away. And what other number is also 4 places away from 0 on the number line? That's going to be -4. So I'm going to make sure that I fill that in with a closed circle. And now I want to shade the part of my graph where my numbers are, if I'm looking at this, less than 4. And guess what? Less than 4 places away from 0 on the number line. Guess what? -3 is less than 4 places. -2, -1, they're less than 4 places away from 0. 1 is less than 4 places from 0. 2, 3. All of those numbers in between -4 and +4, all of those numbers are the ones that are less than 4 places away or 4 places away from 0 on the number line. So let's go ahead and write our solution statement in terms of the -4 and the +4. So if I'm looking at my graph, remember x is everything that's been shaded. Let's look at this, -4. Everything that has been shaded is actually what? Less than or equal to or greater than equal to -4. Guess what? They are greater than or equal to -4. And let's go ahead and look at this side. Everything that I shaded is actually less than or equal to +4. Remember what I had previously said about when our original inequality is less than or a less than equal to? Do we use the word and or do we use the word or? Here, if you recall, we're going to go ahead and use the word and because I'm using less than or equal to. That makes this a conjunction. Okay, so let's go ahead and see what a disjunction for an absolute value inequality is going to look like. All right, so if you jotted this down, you have noticed that this says that the absolute value of x is greater than 1. Greater than 1, which means that we're looking for all of the numbers on the number line whose distance from 0 is bigger than 1. So I know that anything to the right of +1, any number to the right of 1 has a distance that's bigger than 1, has a distance to 0 that's greater than 1. Oh my goodness, and guess what else? All of the numbers that are to the left of -1 also have a distance to 0 that's bigger than 1. So I'm going to shade everything to the left of -1 also. All right, so let's look at what our graph is saying over here. In terms of that -1, basically what we're saying here is that we shaded all of the numbers whose distance to 0 is, I don't know what I just did. There we go, less than -1, because all these numbers to the left of -1, remember, those are numbers that are smaller than -1. Looking over here, what we're saying there is that all the numbers that we shaded are bigger than 1. But if you recall, what did I say when our original inequality is greater than or greater than equal to? We're actually going to use the word or in our statement here, which makes this a disjunction. All right, I want you to go ahead and practice this one on your own. The absolute value of x is greater than 5. I'll give you a hint here. This is a disjunction. So make sure that you do this on a number line. Write out a number line and shade properly. And then write your inequality solution statement. All right, so let's go ahead and kick this up a notch. Let's take this one step further. What we're going to do is we're going to take this absolute value inequality and we're going to solve it, and then we're going to graph the solution. So let me tell you how we want to solve something like this. All right, so I'm going to do this very similarly to how we did the absolute value equations. So I'm going to go ahead and I'm going to write this without the absolute value symbol. Keep my inequality how it is. Everything stays the same. I just got rid of the absolute value symbol. And because my original inequality is less than or equal to, then that means I'm going to go ahead and use the word and. I'm actually just going to go ahead and use the symbol to save some space. Remember, this is the symbol for and. All right, and if you recall from absolute value equations, I'm going to rewrite this. That 10 is going to become negative, but notice what I'm going to do now with my inequality symbol. I'm going to flip it to the other direction. So this is going to be a little different from absolute value equations. You just have to remember that we're going to flip the inequality when we're writing the second equation here. We're going to go ahead and solve the left inequality. We solve that by subtracting 5 from both sides, which is going to leave us with x is less than or equal to 5. And now we're going to go ahead and solve the right side inequality. And for the right side, we still do the same process, subtract 5 on both sides. This time we're going to be left with x is greater than or equal to -15. Okie dokie. So let's go ahead and graph this solution, the solution to this on a number line. Remember that this is a conjunction. So I'm going to graph them both above the number line first, and then I want to see where they overlap, and then that overlapping portion is what gets placed on the actual number line. All right, so I'm going to go ahead and graph this section first that says x is less than or equal to 5. So because that is a less than or equal to, that means closed circle above 5 there. And everything that's less than that is to the left, just like how my inequality right here is pointing to the left. Now I'm going to graph this next section that says x is greater than or equal to -15. So it's still a greater than or equal to, which means closed circle above -15. And I want every number shaded that is bigger than that. So that means I'm going to shade to the right. Beyonce doesn't have a song for that. Anyway, making up my own music here. Now we want to look at where these two overlap, and I can see that they are overlapping right here to right here. So that's the section that goes on the number line. Closed circle at -15, closed circle at 5. We're going to shade all of that in between because these are all the numbers that are going to be solutions to this inequality. And then we can actually take this graph and write its solution as a combined conjunction, excuse me. And what we're basically saying here is what's exactly on the graph, that negative 15 is less than or equal to all my shaded numbers x, which are less than or equal to 5. All right, my dears, and let's go ahead and do this last example, which is showing us that we actually have a greater than symbol, which means this is going to be a disjunction, which means when we do this graph, we just want to graph everything. That's going to be a solution. So the first thing we want to do, though, after we write down this absolute value inequality, guess what? We're going to rewrite this without the absolute value symbol. So if you've gone ahead and written it out without the absolute value symbol, you should have written it this way. Negative 3x plus 6 is greater than 18. And remember, this being a disjunction, we want to use the word or. And just so I can save some space, I'm going to go ahead and use the symbol for or, which looks like that. And then I'm going to write my second portion. Now my second portion, remember, everything stays the same except my 18 is going to become negative, and I am going to flip that inequality around. So now it says that we're using less than. Negative 3x plus 6 is less than negative 18. And now guess what we get to do? We get to solve each one separately. Let's go ahead and solve the left side inequality first. So you're going to subtract 6 from both sides of that inequality, which is going to leave you with negative 3x is greater than 12. And I know you know this next part. Divide both sides by negative 3, which, please, don't forget, when you're dividing by a negative, what happens with that inequality symbol? Bam! It switches directions. 12 divided by negative 3 is going to give us a negative 4. So we're looking at x is less than negative 4. And now on to the right side, inequality. So we're going to do the same thing that we did just a second ago. Subtract 6 from both sides. When we subtract 6, that's going to tell us that negative 3x is less than negative 24. And divide both sides by 3 so we can get that x all by itself. And remember, dividing by a negative means the inequality turns this way. Negative 24 divided by negative 3 is 8. There we go. So you should have now x is greater than 8. And don't forget that we are still using this symbol because this was a disjunction, an or statement, based on our original inequality being a greater than symbol. All right, now what we want to do is graph the solution here. So please don't make fun of my number line. I know it looks very sloppy, but you know what? It's just going to have to do for right now. So anyway, you got your number line drawn. What we're going to do is graph that part. So remember, this was a disjunction. So what I want to do is I want to graph both of these on the number line. I want everything that makes both of these inequalities true to go on the number line. So first I'm going to graph my x is less than negative 4. So because that's a less than symbol, open circle at 4, or excuse me, at negative 4. All the numbers that are less than that are actually the numbers that are to the left. Remember, same direction that that inequality is pointing kind of gives you a hint there. So that's x is less than 4. And now let's move on to this x is greater than 8. So I'm going to get an open circle at 8. Because remember, we're not including 8. And where are all the numbers that are bigger than that? To the right of 8. So I'm going to shade all the numbers on my number line and even that arrow because we got to shade that arrow to let us know, let everybody know that we're still going on in that direction. So even the numbers that are bigger than 9, 10, 11, 12, those numbers still are a solution to this. So What we can do is leave our solution, our final answer, like this. We don't necessarily make a combined conjunction or a combined disjunction. Leaving it this way is perfectly fine. All right, guys. So this was the last example for this video, at least. Tomorrow when you come to class, make sure that you are ready to practice. And I'll see you tomorrow, guys.